Thank you for joining us from different parts of the world. Every month, NDT Talks brings together industry experts to discuss the challenges, opportunities, and innovations shaping the future of non destructive testing and asset integrity. Today's discussion focuses on an industry where every inspection has the potential to influence not only operational performance but also the safety of people, assets, and the environment. Our topic today is how can NDT be the game changer for safety in the oil and gas sector in 2026? The oil and gas industry continues to operate some of the world's most complex and demanding assets. Many facilities are aging, operational expectations continue to rise, and organizations are expected to balance safety, reliability, sustainability, and cost all at the same time. At the heart of these decisions is non destructive testing. Modern NDT is no longer limited to defect detection. It plays an increasingly important role in asset integrity, predictive maintenance, risk assessment, and operational decision making. Today, we'll explore how inspection strategies are evolving, where technology is creating the greatest impact, and what the industry must do differently to build safer operations in the years ahead. To guide this conversation, we are delighted to welcome our moderator, Daniel Hook, along with an outstanding panel of experts representing material engineering, inspection technology, research, and asset integrity management. Daniel, over to you.
Yeah, thank you very much and welcome everyone. It's a pleasure moderating today's panel discussion. I'm very excited for it. And when people think about oil and gas conversations, they often focus on equipment reliability, regulations, and emergency response. But every incident investigation eventually asks the same question: could this be prevented? Sometimes the answer lies in better maintenance, sometimes it's better engineering, sometimes it's operational discipline, and sometimes it's simply recognizing what an inspection was trying to tell us before the problem became critical. Today's discussion isn't about identifying the best technique. Instead, it's about understanding how inspection contributes to better engineering decisions, stronger asset integrity programs, and ultimately safer operations. We have an exceptional panel of diverse experiences, so I encourage everyone to share practical examples, challenge each other's perspectives where appropriate, and make this an open conversation rather than a series of individual presentations. So, leave your comments and we'll try to get to them at the end of this. So the first question: safety has always been a top priority in oil and gas, yet incidents continue to occur across the industry despite decades of experience, regulations, and increasingly advanced inspection technologies. In your opinion, what do you believe is the biggest challenge preventing organizations today in achieving consistent, safer operations today? Anoop, if you want to start with that.
Thank you, Daniel, for that wonderful introduction. And Prajnal, thank you so much for organizing this event. And Prathamesh from OnestopNDT. For coming back to your question, I see the major challenge as the oil and gas industry's reluctance to adapt new technologies. Commonly, when you talk about quality managers or QC decision makers from the client's end, they are often very late in adapting the latest of technologies in the field, when compared to other industries prevalent. For example, AI or digital twins or any other latest of technologies. So that takes a lot of convincing at multiple levels and levels of bureaucracy. It could be stages of approval, but at the end of the day, it's just ease of process, in my opinion, to adapt. Thank you.
All right. Who's next?
Yeah, I can be the next. I'm Urvesh Pala. I'm from Larsen and Toubro. So, I just want to add is in biggest challenges with respect to gap between inspections data and engineering decision making, as I'm part of EPCE part, that is engineering. So I just focus on that NDT plays a very vital role when we are working with proper NDT technique and the advanced tool which we want to use as an inspection technique for any material of constructions. Like if there is a, for example, if the stainless steel is there, then UT having some limitations because UT has a one phase or standard which is having limitations. So material of constructions with respect to selections of NDT technique is again a challenge. Many cases we see that there is a defect, but it can't measure. But now there is a sophisticated probes are there, which now with POFD, TOFD, and POUT, this can be minimized to a certain extent. But it is not eliminated for single phase material like stainless steel. Also, service environment is also important for us to know because we select material for entire refinery. In that case, service environment and NDE methods and extent of NDT is also very much crucial for us to select because the corrosion mechanisms is different based on different services which we choose. So there, building metallurgy challenges are also important. For example, if it's a lightweight S2 service, then certain restrictions for weld and base material testing and extent of testing with respect to NDT is more important for us to go. Even the design code restrictions also we have to see based on the geography where the equipment is get manufactured. European code is different, American codes are different. So that particular things also we have to keep in mind. Other is fabrication history because the history is also playing important role for NDT because the fabrications processes like what are the process, how it produced, what are the heat treatments going to affect that process is also good for us to know. Of course, operating conditions for the plant that is also to be keep in mind. For example, the depressurization calculations and upset scenario is another big challenge for us when we select material and extent of NDT. And lastly, the future inspections and maintenance strategy, which required based on the material which we are going to discuss about. So these are the certain challenges which is really there for any EPC projects to execute across the globe. So this is what from my side. Thank you.
Okay.
Yeah, thank you. Jones, you want to answer that one?
Yes, thank you, Daniel, and thank you for this opportunity to be part of this distinguished panel and discussing one of the hot topics of the industry. So each organization, each operating company has this challenge, and they have been spending millions each year for inspection, but still they are not able to achieve their targets of process safety. So this is a big challenge that the operators across the world is facing. And if you look at the root cause, there are few root causes that are still not addressed properly. And if you look at the inspection technologies, there are a lot of inspection technologies. And over the past 10 to 20 years, we have seen a lot of advancements in terms of the advanced NDT techniques that has been developed and the application. And we see what we were not able to do in the last 10 years or so. We have achieved great advancements in terms of the technologies that we have that we can use. But the key part is translating this inspection data into engineering decisions. So, okay, for the past 10 years, you have done inspection. So what do you learn from this data? And how do you make your engineering decisions? And how do you improve your inspection strategies and program? I think that is a key part that the organizations has to focus on so that they can improve from year on year and use the right NDT techniques, right NDT tools. Of course, you should have a proper inspection department which has expertise in suggesting or taking up the correct NDT methods that needs to be used. At the same time, a very sound engineering department should work who looks into this data and makes proper, wise, sensible decisions in terms of the inspection strategies that the company has to undertake so that in the future, from the lessons learned from the previous incidents or from the previous years, we improve. From year on year, we have a better improvement. We can see that by better application of improved inspection strategies, you can achieve better target of process safety. I think that's the key in improving the safety performance of each company.
Okay.
Yeah, and, Ramon.
Yep. I think that, well, every year I have the opportunity to collaborate to interact with companies located in 5 continents, and this includes not only oil and gas, but all other sectors which also have critical safety and reliability assets like aerospace, chemical processes, pressure vessel manufacturing, structural steel construction, and biotechnology or health services. So I have a little more critical perspective on that. And I should point the analysis in like 2 layers. The first one is the biggest challenges of the oil and gas sector, in my experience, varies not only by geographic region, but available infrastructure or technology maturity, which are uh, tangible assets, but also for some intangible assets like organizational culture, operational structure, workforce characteristic. So those challenges we can analyze it in like 2 layers. The first one has to do the general challenges that every industry faces, like the erosion of true safety culture by financial or performance demands, or the when safety critical inspection and maintenance investments are not treated and safeguarded but are contingent to business decisions, or the increasingly accelerated gap between available inspection technology and what has been truly deployed in the field. I have seen companies that invest thousands of dollars in phase array or food matrix capture technology and are being outperformed by inspectors with simple flow detectors because they are not able to use it properly. And also that, and for example, the fragmentation of regulatory landscape on safety issues for the sector, it varies from region to region, country to country. And this is the general, and many industries face the same challenges. And for the oil and gas specifically, also are those challenges that are associated with the substances and the materials that are inherent to our sector. So this is my perspective for analysis.
Yeah, that's a great point. So we've established that technology alone isn't the answer, but it does bring us to our next question. It's kind of relevant to what you were saying. Also, is organizations today have access to so many inspection technologies than ever before. Phase array, time of flight, guided wave, digital radiography, AI, robotics, you name it, it's out there. Has having more technology actually made inspection decisions easier, or has it introduced a new level of complexity? And we'll start with you, Anoop.
Uh, well, to be honest, it's in my opinion, it has raised a little bit of complexity from the inspection service provider point of view, as most of my experience has been from the inspection provider point of view. Mostly it is from the regulation and client's approval of the technique and of the procedure and of the equipment and the manpower who are skilled or not. And when it comes to new technology, it is often more noticed that the client and the end user often are less aware of the new technology to get exposed to. So, in my opinion, from the regulatory standpoint, when a government body or a organization body who is regulating has to keep awareness sessions, while the manufacturers also nowadays are conducting most of these training sessions or free introductory training sessions, technical sessions across the world wherever they are trying to sell those equipments. And in addition, the inspection companies play a big role where they'll have to train their manpower sufficient enough, at least capable enough to use those equipments at site and do it competently.
Yeah, I agree. Dr. Bala, do you have any insights on this?
Yeah. So, like, normally what is discussed, like POFD and TOFD, I already told that like POFD is excellent UT methods for volumetric examinations, but there is a problem with respect to the skill for interpreting their data. So those are real challenge what we normally face when we go with some advanced technology. For example, TOFD again, crack sizing and limitations near the surface is also a problem. And if you go for a digital radiography, then the interpretations and handling of digital radiography is totally new with respect to traditional radiography management concept. Even now robotics which is there in the picture, so that those are again going to be a game changer with respect to the operator's skill, because whatever you want to go with normal with hand and with robotics or remote inspections techniques, where you need a totally different mindset and skill for that data to interpret. So yeah, there is a merit and demerit. There is a risk. There is certain good things that the new technology brings, new acceptance standards, code standard has to revise, and a lot of things need development. For example, end user specifications need to change with respect to new technology, and even their limitations with respect to acceptance criteria. So those are really good for us to do, and a lot of work is required in this area, because when you go for digital radiography, then the limitations of digital radiography versus traditional radiography is to be balancedly understand, and that interpretation is required some different skill than what we have now. So yeah, of course. But anyway, the final conclusion is always good to go with advanced technology and advanced interpretations. And nowadays we have a AI which interpret result as well. So let's see how best we can train AI modules or the database which we have for that to interpret the actual defects which we generated through robots or through advanced ND methods, which is going to help us in future. So this is my takeaway for this question.
Yeah, good points. Mr. Jones?
Yeah, it's a good, interesting question. Yeah, actually, as I mentioned, we have been seeing advancements of technologies, and we have more options in our table to choose than we had few years ago. So in a way, it's beneficial for the people to choose. They have wide range of application or wide range of options to choose from. But the key part is choosing the right tool for the right damage mechanism that we're looking into. So yeah, you might need ultrasonic, just conventional ultrasonic testing for a particular application, and you don't have to use phase direct because you have that option with you. So it's the right decision to make, and also the damage mechanism what you're looking for, which technique is suitable for that particular application, and how you balance the cost and the effectiveness of using those tools. I think that's a key decision that you have to make, that comes from your experience and also the know-how about the new advanced technologies that are available in the market. For example, in our assets, we have the problem of corrosion under pipe supports, and until 5 years ago, it was a real problem that we were facing. And most of the time, we had no option other than to lift the pipe supports and cut and replace during turnarounds. But now we have been using advanced NDT techniques like QSR, quantitative short range, and also higher order mode cluster, which is all ultrasonic based techniques to quantify the wall thickness under the pipe supports. So in a way, we can say these technologies have really helped to optimize turnaround durations and cost, and also help to make the assets safe, and also take this informed decisions before a failure happens. Thank you.
Yeah, that's great. Ramon, what's your perspective on this?
Okay, well, I can add two elements. The first one is, and I tell to my students, those are great news or bad news, however you see it. First, uncertainty derived from increasing accelerated change, either disruptive or gradual, is at the core of many strategic decisions in the industries, and particularly in oil and gas. And also, we are living in an age of accelerated complexity, in not only in the business environment, but also in how we use a series of critical and emerging technologies such as artificial intelligence or advanced manufacturing processes or advanced engineering materials or robotics. So we should think how we should adapt and evolve in this environment of uncertainty or accelerated change. That is why I think that at the core, and this has helped me, is to understand how technology is managed, because it is not only about adoption of technology, but technology management systems has a series of 5 steps: technological surveillance, what is happening around us, and from those technologies we should plan how which technology are relevant for us, and from there how we align our processes and our collaborators, our systems, our communication infrastructure to have this together, and how you enable those resources, and finally how to deploy and how to protect intellectual properties associated with that. Because if not, you seeing that people are choosing wrong technologies due because it is also used by the competitors or used by other sectors. They're not enhancing or enriching the capacities of their personnel aligned with these new technologies, or what is worse, they don't have the information and telecommunication infrastructures, or they have more data and they're flooded by data, and they are not able to transform that data into information and knowledge to support relevant decision making processes.
Yeah, that's a great point because technology generates information, but the information alone doesn't improve safety. So that's going to tie us to our next question. Is one of the biggest conversations in the industry today is around digital transformation. Organizations are collecting more inspection data than ever before, but that data only creates value if it influences decision. So how effectively is today's oil and gas industry turning inspection findings into meaningful engineering and maintenance actions?
So Daniel,
Anoop?
I noticed that today's current day and age, we have paper piles of documents and files sitting in their desks and offices, but often very rarely used except for inspection and insurance needs. Mostly, I've noticed this also that from the oil and gas client's perspective, whenever an inspection service provider company gets them a report, inspection report, NDT report for that matter, it goes through a series of approvals and reviews, and after that it is filed and it'll sit in their office for the next 5 years or so until the next inspection schedule comes in. When sometimes they do review those previous reports and sometimes they don't. Which is why I was speaking of digital transformation, mostly digital twins and visualizing the real-time NDT data, and at least installing IoT-based sensors and getting the live feed of inspection data and onto a dashboard where they can consistently monitor and act upon it rather than sitting information which is of no use at all.
Yeah, that's a great point. Dr. Vala?
Yeah, so like AI in NDT, that is playing a very big role now, because there is now no man's zone refinery concepts are there in place. So to overcome those challenges, and even non-contact duties are developed for under insulations defects to verify. So those what we say that the defects is to be monitored with respect to the new challenges. Even if we say RBI, EPA 580, 581 have introduced new methodologies, even they are going for the sensor-based technology, by which the corrosion under insulations are normally get detected. Even we have a predictive maintenance concept which is there. Even we have a digital report generations systems for all the assets. So those data are live data which normally require certain high level of interpretations with respect to the degradations, damage mechanisms which is there in entire refinery. So we as a EPC projects, we have a lot of challenges with respect to material selections, with respect to welding procedure qualifications, fabrication quality requirements, as well as on the coating and lining integrity to verify. So of course, the things which we want to understand is beyond the normal inspection methodology which we have, like automated defect recognitions in radiography, if something like that, some new things by which we improve our efficiency, repeatability, and we get real-time data, and that is giving the accurate analysis of the defects. So those NDT methods, which is really good for us to address. So that is what from my side.
Yeah, great points, Mr. Jones.
Yeah, I think it's an interesting question. Again, there is a lot of interest in the industry to use the inspection data that is available in their organization since the emergence of the artificial intelligence. So the people who understand that and have implemented that are well ahead of the race. So organizations, they have a lot of inspection data, tons of inspection data sitting in their repository. But making engineering decisions and making smart maintenance actions out of this inspection data is the key. So as you see, the digitalization emergence also is quite relevant in almost all parts of the globe. So all organizations want to digitalize their inspection strategy or whatever they are doing. And for that, translating the inspection data into meaningful decisions, and doing predictive maintenance and predictive analysis, and understanding corrosion patterns, and developing inspection plans, and improving the maintenance planning based on this predictive analysis is key for the digitalization efforts that we have been seeing. So it's a very subjective question, but we see there's a lot of interest across. Sure, the organizations will look into this to translate their inspection data into meaningful engineering decisions. Thank you.
Yeah. Awesome.
Yeah,
Thank you, Ramon.
Okay.
Oh, yeah, go ahead, Bala.
Yeah. So actually, I just want to add one thing is like now is AI assisted and NDT is the new approach, which is new in inspections technology. Even if you go for ND 4.0, so that is also having many things integrated, like AI with machine learning, robots, cobots are there, IoTs are there, cloud computing requirements, and digital twins. So these are into various data, and then it is going to map with the actual defect what we received in live refinery. So those things are also very much important for us in decision making, real time analysis, or automations which we think of in present scenario for NDE. So that gives productivity as well as the repeatability, and it gives more confidence in new technology adoptions.
Yeah, great point. Ramon?
Okay, as I was saying, and this is aligned with my initial answer, I have the opportunity to see a lot of companies through the year, and about digital transformation. Some people still think that taking an NDT report in paper and scanning and sending by email, this is digitalization. But this is the lowest degree of maturity, and I have witnessed, and I'm working with organizations that are using integrated digital platforms. They're using augmented reality, and they are not only digital twins, but has digital threads of their facilities. So I think that two ideas are core here, and this is a reflection for everybody who's attending this talk, is how is your digital DNA? I didn't have this notion of digital DNA until one customer told me about it, about my own organization, is how these digital technologies are integrated into everyday projects in all instances. And also, it is important about the ecosystems. I call it ingenuity ecosystems, where how you are interconnected with your stakeholders and you're sharing information and data and knowledge through that. So this is this is relevant. How is your digital footprint? How is your data ownership and privacy? How you're protecting data security? So this is two ideas that are relevant for, and this is moving forward. The idea is, how can you transform this implementation of digital technologies into real impacts on safety? Because, for example, I have the other day in a facility of a customer, they say, okay, we have digital twins, but the digital twins are often static visualizations of models they have in a computer, but they are rarely refreshed. They are disconnected with live inspections or sensors. So at the end, they need to transform into decision supporting tools.
Yeah, great point. Yeah, if you got a digital transformation and it's not or digital twins and it's not connected to real life applications in the field, then you just got 3D models or doing yourself a disservice. And good point. So let's shift from technology to people, because every inspection still depends on human expertise. As artificial intelligence becomes increasingly integrated into inspection workflows, many believe the role of inspectors will change significantly. Do you see AI becoming a trusted decision support tool, or are the aspects of inspection that should always rely on engineering judgment and human expertise?
Well, to start with, I don't see AI at that stage yet. I'm very confident that AI will be at that stage in the near future. Particularly when it comes to the current stage of AI, many companies claim that they can do AI-assisted interpretation, AI-assisted analysis, or some even claim AI-assisted equipments to do the complete scanning and it'll get you a report. But in NDT, most of the AS&T level 3s would already know that there is something called probability of detection and reliability. That is something of really essence here. When an AI interpreter is performing a PAUT, let us say data analysis, how sensitive is it in finding a tiny defect, or segregating two tiny defects that are very close to each other, which is resolution, nothing but sensitivity and resolution. So I strongly believe AI is not up to that mark yet, and I'm very sure it'll be up to that mark in the very near future. And when it comes to inspection data and taking informed decisions, assisting QC managers or decision makers from the client's end to take the call in a jiffy while having all the data given to the AI, I believe that is something which can be done at this level of AI at this moment. And the future is for us to see and wait.
Yeah,
Okay,
great
Daniel.
points, Doctor. Yeah, go ahead.
Yes, Daniel, if we want, this is a subject that is very close to what we do every day. So one of the things is, you need to understand, and I tell my students about it. So when you look about technology adoption, normally ND technologies are nurtured by two main sectors, that is military technology and health sciences technology. For example, digital radiography, it is prevalent on the health sciences. So we need to look at, and in the same perspective for artificial intelligence, we're seeing in the health sciences that artificial intelligence assistance is something that is more mature that we have now in ND. That is why I am participating in an AS&T's committee on artificial intelligence and machine learning, and I'm leading a research group that has to do about ethics and human factors on artificial intelligence. Because in our company, we have been doing for 40 years the developments on AI. So there is two things. The first one, we need to see artificial intelligence not only as a single monolithic thing, but also a part of a more advanced series of critical and innovative technologies with other technologies, as I said before. And from there, we have this style, a series of five principles. One has to do with maintain human-centered decision-making. Regardless of you have AI assistance, you need to maintain human-centered decision-making. Also, you have to establish for artificial intelligence comprehensive governance frameworks. And connected with that has to do with ensure transparency and explainability of the models, because people sometimes see artificial intelligence systems as black boxes. They don't understand how they work about. And two more additional things. We have to implement rigorous validation processes for the training processes and the deployment processes, and address ethical considerations of AI in a form that is proactively, not when you deploy and you have your ethical concerns, but have it that proactively addressed. So this is my take on that.
Yeah,
Couple
good
of points on
points.
what, sorry, a couple of points on what Ramon just mentioned. When you're speaking of AI, obviously the quality of data which is being trained to nurture the AI model also comes into picture, which is not very promising, and consistently it is not a quality data, and somebody has to clean all the data. So the cleansed data again have to be significantly large enough to support and train an AI model good enough that it will further do the inspection, interpretation, or whatever it has to do.
Yeah, great points.
Yeah.
Dr. Vala?
Yeah. So yeah, is enough thing was discussed for this particular questions. But I just add one thing here, like based on the oil and gas refinery constructions experience we have. So normally this AI is going to be certainly going to be the good decision support for I think NDT staff which working at the site, because AI is giving you some image recognitions. So that image recognitions quality, like today there are certain issues with respect to the image recognitions tools which they are recently using at our site. So there challenges are there, and all is what we depends on is the brand. So now from there to the real standards that every one of the operator can help us to give proper quality, because for example, if the equipment get fabricated at one locations and it transport to the site, and then there is some failure analysis is to be done, and that tool and other tool having a different. For example, if we go for digital radiography for both place, but of course the image recognitions at both places is different, and that makes some decision change. So those cannot be done by AI. It is required. The human interventions are required, because that your human touch is always there. He is not like AI is going to change everything and eventually replace human and human judgment to the large extent. It is not possible. Even defect pattern identifications is unique with respect to welding processes which we have. So to get those everything data, even we have a three process together. For example, we had done a TIG, SAW and SMAW and SAW. Then if you want to check and verify, so human can immediately recognize with respect to WPS BQR. Because we can ask ourselves the questions that what is the problem going, because of which reason, how the slag formations is not part of TIG and is part of SMAW. So this decisions is not really taken out by AI tools very effectively. Otherwise, like historical data comparisons is very difficult, because humans have the history for one live plant, so they know which process is corrosive, which process is going to be immediate shutdown, or which process need more ND methods to check, and some portions having for example the end where we can say the dead legs are going to form. So those judgments, if we go with certain AI tools, it won't find. It is the person who go and inspect everyday basis can realize that this portion is really tough for me to check. So these are like this. There are many other like predictive maintenance, or you can say risk-based prioritizations, and easy winning of the data interpretations are always a challenge. So I agree that AI is not going to replace human interventions 100%, but yeah, of course, it add value to the system by which our decisions can be validated fast.
Yeah, good points. Mr. Jones?
Yeah, I think very interesting facts shared by the panel members. And it's a very interesting question also. So I do totally agree that yes, for the current scenario, the current state of development, AI can only be considered as a decision support tool. If you ask me if is it a trusted decision support tool, I cannot fully agree to that because AI is still transforming. It's still developing, right? So the trust that people have on AI is still building. It's not fully there. So we are still in a transformation journey. We have to build that confidence among the organizations that AI can do the part. But again, it has certain good features like you can identify hidden pattern. It can analyze large data sets, and also it can predict degradation trends. So for all those repetitive activities, AI can be used. But when coming to engineering judgment and also to decision making, and also you connecting the dots, right? So there are different departments which work in different. Some work in isolation, but somebody has to bridge in the data together to take sensible engineering decisions. For example, you have the operation history sitting with the operations team, you have the process conditions sitting with the process engineers, then you have the degradation mechanism data sitting with the corrosion engineers, and all this data need to be integrated. So someone from the engineering department needs to work together to bring all this data. At the same time, use AI to analyze this data and make meaningful decisions. So from engineering perspective, I think still humans need to take the call. They need to work so that realistic, real world, actual decisions can be taken. And also we can build confidence within the management that we are moving in the right way, and it's all checked and it's all foolproof.
Yeah, great points. So beyond technology and people, there's another factor that often determines whether inspection programs will succeed. Inspection programs don't operate in isolation. They often have budgets, production targets, scheduled shutdowns, unscheduled shutdowns, resource availability, and they all influence decisions. How can organizations maintain strong inspection standards while balancing operational pressures and commercial realities?
Hey Daniel. So and the panel members. One of the key word which I mentioned is budgets. I've noticed that competition is very aggressively there in the market. There are tons of companies nowadays who are popping up and competing against each other to win a bid or a project. And all of this reflects when they are executing the project again. When somebody bids to win, they go as low as they can, sometimes below the market level, and so they try to cut down the cost while they're executing, which sometimes reflects on their inspection quality. Sometimes it reflects on the technicians' capabilities because they're not trained well enough, or they're not using popularly known equipments. They're using cheaper alternatives for them. So these are all coming into picture. These are all the challenges which inspection service provider companies are facing in the real world market, particularly if you're talking about Middle East and Indian side market. I'm not sure how that is in the other side of the world.
Yeah, that's correct. Anupul. Like normally we work for EPC projects globally, so there the challenges are like this because our main target is the schedule. So we have to stick to the schedule, and that schedule is to be maintained at any cost. You cannot cut down the welding requirement. So welding time you cannot cut down. You can only cut down the time is the inspection time. Yeah. Or the parallel inspections together. So these are the real challenge. You rightly pointed out that you cannot have welding like preheat, post heat, interpass temperature. You cannot do any compromise in that. But for NDT, you have to compromise with respect to time. Maybe you have to do it the night because it's a volumetric analysis. So people has to go for extra mile and they have to work for meeting the schedule. Also, the commercial commitments are there because everything is a milestone which our commercial team has to work for. So they always pressurize technical team, mostly inspections team, that please clear it, that it should be in acceptance criteria, it should meet the requirement, and you please go with the next mechanical clearance of the plant. So yeah, of course, challenges are very good, and there is shutdown windows are very low if we are going for say maintenance activity shutdown. So there the inspection window time is given, we have to complete by 2 days. So actual repair is to be addressed, or we have to validate that yeah, it can work for 5 years. Another shutdown will take those precedents. So the challenges of ND guys is really tough. And sometimes now the new technology says you can work for high temperature NDT. So those also are added in the cost rider, because you don't want to cool the weld joint, but you want to do NDT immediately. So those high temperature NDTs are now going to play in shutdown activities. Also, there is a client requirement. So client sometimes ask some stringent requirement which is beyond the codes and standards. So there also we are helpless, and we want to use all the things which they want from us to do. Even if you see the risk-based inspection planning also having certain strategic NDT requirements. So when we say RBI, the initial stage of plant is a very lenient, but after 5 years, yeah, of course, and after 10 years, when they go for internal thickness measurements or the laws or corrosive products identifications, is really challenge for NDE guys. Sometimes they say we don't want to stop the process and we want that NDT go with some NDT methods by which we want real-time analysis as well as we get what corrosion damage mechanisms are there. So yeah, so checking those things with certain floating sort of NDT methods is the sensors which give photographic image as well as it gives the thickness measurement. So it's really good challenge for us to address those requirements. So yeah, of course, cost and time, where time is precious, there are a lot of labs which I observed in current situations for ND, especially ND guys, because they are struggling round the clock to meet the customers' expectations. And if something fail, first question comes that what is the ND method used, whether it is really foolproof for this particular joint to verify. If not, then why we have not taken decision that time? Yeah, so this is really good point for every one of us to go and find, and alternative ND methods, what inspection methods you use, why you have not used something different than what is traditionally there. Because when premature failures are there, is really a big challenge for us to define with respect to, because ND only tool which says that material is okay to proceed for 5 years for the next shutdown. So yeah, Anup is rightly pointed out those challenges are really good for us to address as a EPC player.
Yeah.
Yeah, sounds
Yeah.
great. Mr. Jones?
Yeah, I think it's an acceptable fact that all the organizations across the world, they are under tremendous pressure, cost pressure and also operational pressure to reduce or to optimize the inspection programs, right? So there's something called the UOC, unit operating cost. So every company targets to reduce their UOC, their burden of operating each barrel. So that really shows how well the company is performing and also optimizing the inspection program. So yeah, there is always a pressure on the inspection department to optimize the inspection strategies. And I think one of the key tools that we have been using for a quite long time is a risk-based approach to understanding the risk of your assets and focusing your inspection programs or inspection efforts on areas or equipments that really matters, right? So you increase your inspection efforts on those areas where the risk is higher, and you reduce your efforts on risk places where risk is not that high or considered low. And also in the near future, we have seen AI-enabled real-time monitoring systems has helped organizations to increase the production, because they are able to do a real-time monitoring of the assets, and also they always want to make sure that they increase or they can improve the production by doing a continuous monitoring, and AI enables that to be done seamlessly. And also there are many automated methods and strategies that different companies across the world have been implementing in the recent past to optimize inspection strategies. So certainly the pressure is there, and I think that's addressed by the risk-based inspection strategies, and also the AI-enabled autonomous inspection programs and the different methodologies that are emerging in the industry. Thank you.
Yeah, I just had one thing here is like you rightly pointed out for the RBI. So like RBI, I'm a part of API 581 committee. So and even the NACE technical committee for various inspection standards. So yeah, the challenges are really very high for the RBI point of view, because now recently what happened, that asset integrity management guys who are in the asset owner, so they don't want to go and do periodic inspections. So they want that change entire material to CRA, that is corrosion resistance alloy, so that they can plan their inspections activity accordingly. So these are the certain the cost riders which normally we get into that. The inspections guys say that no, when we do RBI preliminary RBI for plant shutdown, plant handover, they say no. If there is a deadline, please change to CRA. We don't want anything to be inspected, because we don't want to go in the plant before 5 years. That is our requirement. So do whatever you want based on 3D model, pain ID review, or go through the plant. Whatever you feel uncomfortable where deadline is the case, please change to CRA. So these are really good challenge as a EPC player we have, that such cases where is very tricky for us to address, because every time standby pump is always having a deadline. So that is never solving any those problems with the end user, because standby pumps are always having deadline, and the geometry where the elevations and projections are adjust based on the pipe rack adjustment, and with the vessels and columns setup in the complex structure is really challenging for us to address those scenarios.
Okay. Well, if you allow me, let's give a couple of steps back in, and I will complete my answer with two fundamental ideas. And one of my personal passions is teaching, and every time I give a seminar for ND apprentices, I ask them to write down in their notebooks, we are in the business of saving lives and preserving the property of others. So that means that at the core of the safety should be at the core of every decision that the ND inspector make. So this is fundamental, regardless of technology. There is a human perspective of NDE. And also we need to analyze with a broader perspective. Where do we come from, where we're at, and where we're heading. I'm a child from the 80s, and at the 80s business environments, we were facing on improving efficiency and quality and productivity. But we have moved to, as I said before, more challenging and complexity environments where technology has an effect, and the economic pressures and the uncertainty. So we have been involved in knowledge management and eco-efficiency and digital transformation and democratization of information. But I think that two of the trends that in the present and towards the future is we're moving into a trust economy. So at the end, we need to address how we achieve trust in all the parts of our processes. And trust is an intangible asset, but has profound operational implications. So it has to do how we have predictable and ethical and transparent actions in our inspection ecosystems. And we're moving to idea of what is called vulnerability economy, when organizations are transforming and learning from their mistakes, and they're truly transforming into a culture where, in a business environment where they provide emotional safety and continuous evolution, people are open to uh, express what they feel and express concerns without being the risk of taking out their jobs. And that is why you improve the at the end, the solution needs to have an ethical foundation and sound and engineering principles, but also they have to consider a human approach on safety.
Yeah. All right, let's transition to the next one. And as artificial intelligence becomes increasingly integrated into inspection workflows, many believe the role of inspectors will change significantly. Do you see AI becoming a trusted decision support tool, or are there aspects of inspection that should always rely on engineering judgment and human expertise?
I see it as a support tool for now, and as I mentioned earlier, I see in the near very future that maybe robotic AI-based inspection will take the NDT world over. But there are other critical aspects which are to be discussed from the regulatory point of view. For example, if we are see most of the NDT level 3s working for inspection service provider companies often sign off the procedures, right? Most procedures are based on the client specification. Client specification is again based on the standard or a code. Now, when an AI-assisted inspection or interpretation is taking place, are they amended into the procedures? Are those processes approved by the regulatory bodies or the clients which you are serving to? Or what is the reliability? Have you tested and demonstrated those reliability, probability of detection, sensitivity, and resolution of those AI processes which are taking into place? For that matter, even in the current day and age, I've seen that most inspection service provider companies who are creating project-specific procedures are not actually demonstrating it. They're just signing off those procedures and sending it to the client level 3 for their approval, and they bring it back, which is not the right thing to do for obvious reasons. They'll have to create a procedure, which is a step-by-step process of how to do the inspection. Then they demonstrate it with their inspectors and said equipment, calibrated equipment, obviously. Then the client's level 3 will witness it and notice that probability of detection, consistency, and the reliability of the method. And then he signs off the procedures against the inspection service provider company's level 3 signature, I mean to say. So such sort of solid procedures, such sort of standard processes have to be implemented when we are talking about AI in the near future implementation. That's my take on this. Thank you.
Yeah, that's correct. Based on like EPC prospects, if we say for any refinery building activity, so there now the new era for any organization that can integrate ND data. That is one important thing. Second is the RBI approach, because if RBI approach is well taken care for ND requirements, also digital twin, which normally required a lot of data. So those data, if it is available for that particular plant, for example, SRU, sulfur recovery unit. So those data available in digital twin for that plant is going to help us. So that is also important. Other is corrosion management programs for that particular refinery. So we know the damage mechanisms, we know the corrosion loop, we know the inventories which going to generate for the safety hazard. So that particular point is also important for us to know. Also, material engineering requirements. So whether we have used the right material for the design life, 25 years, 30 years for that plant. So that also going to make a lot of impact. Also, fitness for services for the asset which we are thinking of. So there also the decision is very clear. So now organizations need to go with the advanced technology. For example, AI assisted data analysis is required. Then yeah, of course it is the next generation's ND requirements. Also digital inspections record, traceability verifications. Then we have advanced ND like where we can go for any robots or cobots which normally going to generate data, and then it is to be backend interpreted by some AI tool. So I think is a very ideology that we think of now, that eventually those things are going to be there, like robots or remote inspections technology, which is going to work. And of course, this is very good when there is a toxic gases handling plant like S2S, or very where the human lives are compromised. So there, this technology is going to play a vital role, as per my understanding. Also, corrosion and degradation mechanisms training is required for the new era, like what the question is for 2030. If we target, then NDE inspections engineers also to be trained, and regulatory and statutory requirements based on the code standard is to be upgraded to the next level, because the existing the standard acceptance criteria is not going to be the acceptance criteria for the new technology which we are thinking of. So that also a problem, or the challenges which we have. Also, strong interface between EPC contractors and asset integrity team for the asset owner. So those are also to be aligned for the roles and responsibility to be shared. And last is lesson learned feedback from operating point of view for the new projects design, because that is going to reduce your NDE requirements for the plant. So I just say that in future for NDT is not only the finding defects faster because of the technology, but rather it is giving you the predictive risk uh, earlier, so that we can save life, save asset with respect to losses which that particular assets owners are going to face. So we want to have a safe plant, and safety for humans and environment is to be taken care very seriously when any such failures occur in plant. So this is what my takeaway for 2030 with respect to technology revolution.
Okay, if you want me, I can jump in. Looking ahead to the 2030, I think that we should harvest some of the trends that we're witnessing right now in our favor. One is we are permeating the ND competencies and digital competencies into not only an ND inspector, but throughout the organization. That, you mean the engineering and the operational part. And also we are watching how ND technologies, for example, infrared sensors, are integrated into consumer products. So, and the smartphone and the tablets are becoming digital hubs for ND processes. So we need to harvest that in our favor. One other thing is, instead of investing in specific technologies, we should be constructing tailor-made critical and emerging technologies portfolios that make sense to our geographic region, our specific sector, and how we are investing on a specific industries. Also, the diversification of the digital platforms and the development of diversified set of agnostic data file formats. And moving forward, we should be investing more in mentoring programs, because we are having an aging ND population and we're not transforming that knowledge into other inspectors. And in order, and this is I was in a meeting with the leadership of ASNT, and how we have the support from private organizations, educational institutions, and government authorities to work together and create those collaborative networks in order to advance NDE as a field in as a general, and specifically for oil and gas over the next 5 years.
Yeah, I think going ahead, defining a truly world-class asset integrity program is not defined or limited to one single technology. I think it will be a combination of competent people. So you need to have people who really knows the process, who knows how to take intelligent engineering decisions based on data that they have, and cross collaborations between departments, and also having a look ahead, a future vision of long-term asset integrity for the assets. So that kind of long-term vision should be the management needs to have that vision, and there should be people who will be there to enable that. So that's all dependent on competent people. So the right people in the team, reliable inspection tools. Of course, we are having new inspection technologies that are emerging. So use the right inspection tools and technologies that are available, taking sound engineering decisions, and use of the high quality data that we have. So we have a ton of historical data. You integrate that and you use the new data, ensure it's high quality data, and you make sensible decisions and make trending and use that data to make decisions which will improve the process safety of the assets. So organizations should start investing on the improving their workforce capability, digital integration, and continuous monitoring and predictive analytics. So the future is, for me, it's like asset integrity management is more of predictive integrity management, which is powered by AI. Thank you.
Yeah, thank you. Rapid fire questions. Let's see. So we'll do this with one sentence answers only. Question number one technology you're most excited about for the future of oil and gas inspections. Anoop?
Digital twins with AI. That's something I'm really excited for. I'm putting my time efforts into those, which we have a few models, few working models readily available. But I see, I have an opinion that technology shouldn't progress in a linear direction. It should progress in multi-axial direction. Why should it always be AI? Why shouldn't it be 3D modeling, digital twins, IoT-based sensors, and AI all together, and it'll get you a fruitful output.
Dr. Vala?
Yeah, I choose like AI assisted advanced ND combined with robots or cobots inspections together, because this will give you combined effect of high productivity and high accuracy together.
Mr. Jones?
Yeah, I think for me, I'm excited about AI-enabled asset integrity, automated asset integrity management systems, which is a one line solution for all your external and internal corrosion problems.
Okay, I think that we're in the same frequency. I say digital assistance integrated into autonomous cognitive inspection system that has physics-informed and data-driven neural networks. And that means to truly capitalize the expertise and knowledge of human and the inspector and minimize the risks associated for them.
Great. Question number 2. One inspection practice that the industry should stop doing.
Skipping documentation and skipping the training part in the inspection companies. That is something all the inspection companies should stop doing immediately. They should take training more seriously and have more qualitative inspectors come out and do the inspections on site.
From my side, we can go for treating NDT as not only a documentations. So that mindset is to be changed because NDT is done, matter is closed. That approach is to be changed, or we can say compliance activities instead of the engineering decisions tool, which we normally use for closure of any ND and even the further hydro testing and other requirements. Because that hydro testing is again classified in the destructive testing, but again tool is used to verify is ND. So those things is to be eliminated. That is what I can say for this.
Yeah, for me, one inspection practice that the industry should stop doing is the purely time-based inspection. I think we have to totally move away from time-based, and we have to base it on risk of the assets and also leverage on AI capability.
Okay, I have a different one. Remote witnessing of processes of NDE tests, such as leak testing, that are limited to mere video feeds without any access to real-time NDE test data and environmental condition of the test by adequate sensors. That should be avoided.
Good points. So, one skill every young NDT professional should develop beyond technical knowledge.
I would say UT, beyond technical knowledge, is something that ethical skills. Most often times, NDT inspectors start off by taking their UT probe or any other NDT method they would begin with, but they are often left out with the consequences consequences of what would happen if they wouldn't do their job well. So I think ethics should be one of the very good things that have to be taught while they are getting into NDT.
Yeah, from my side, I think understanding failure mechanisms is important for any ND guys who is going to work for. So because if you know the failure mechanisms, then only you can do better ND for that particular problem solving uh, methodology or technique. Also, there is engineering consequence of inspection finding. So this is also going to be improved because if you do that, then only you have that particular IQ or sense of finding the defect. Because if you don't know the failure or damage mechanisms and the consequence which require the inspections to be done on job, so if you have a hand on hand this two scale, of course you will going to give the best NDA methods and the outcome.
Okay, I would say one essential skill and one distinctive personal attribute, that is critical thinking and unquestionable ethical behavior.
Yeah,
Mr. Jones?
for me, I think engineering judgment, is one key skill that they need to have, and also thinking out of the box how things can be improved and how it can be innovative thinking. I think that's one key part. That's how you innovate, and inventions are created by innovative thinking. I think that's one key skill that the new young talent should have.
Yeah, great. Anoop, in one word, what does the future of oil and gas safety look like?
Well, automated inspection process. I am really confident that in the very near future we are going to have automated inspection process. As we know, we have shortages in manpower, skilled manpower, shortages in skilled manpower, and aging NDT population. I think that's one thing I can watch for.
Yeah, I can say is a predictive word. Only I say one word is a predictive. So whatever inspections we do, it must be in the predictive category than in the analytic mode. So my takeaway for the one word, if you want to say, is a predictive inspections methodology.
Yeah, I think I will also align to Dr. Vala's answer. It's more, the future is about more predictive analysis and predictive integrity management than being a reactive. So we totally move out from a reactive regime where we react after problems occur or problems surface, rather than we predict failures and we prevent them well before the problem occurs or is going to occur. So that's the space we need to be.
Okay, in one word, I would say cognitive, with everything that word means.
Sounds great. All right, we received several excellent questions from our audience throughout today's discussion. Let's take a few minutes to answer some of these as quickly as possible. Question: are we looking into automated data analysis or AI to speed up the review of these inspection results?
It's AI-assisted data analysis for now, and ultimately the process have to be embedded much closer to the current process flow, which will take time at this stage at least.
Yeah, because as of now, for AI, the data is not so matured. So that is again a challenge for us now at present. Maybe in future we have more advanced data can predict everything correctly.
I would say I would substitute the question of automated with a smart data analysis or intelligent data analysis. That at the end, I'm involved not only in practical application but also in research. So it is important to use AI tools in order to help us with the data analysis and have a human perspective on that.
I think there is a lot of interest in that space, and active research is going on how to automate data analysis and speed up the process. I think the near future will have strategies and systems or models in place which are doing a reliable automated data analysis.
Sounds great. That's all of our questions there. We'll hand it back over to OnestopNDT.
Wow, what an informative session, you guys. It was amazing. I'm sure our audience would have enjoyed the conversation from our industry leaders. I would like to thank Mr. Anup Rayavarpu, founder and general manager at Atlantis Engineering Consultant, for sharing your expertise on industry transformation and the evolving future of NDT. My
Thank
personal
you.
thanks to Mr. Ramon Fernandez Orcazo, President and CEO of IMENDE, for your inspiring perspectives on global collaborations and advancing the NDT profession. And a sincere thanks to Mr. Urvesh Wala, the head of material engineering technology at Larsen and Turbo, for your valuable insights into corrosion management and the industrial reliability. Lastly, my personal thanks to Mr. Jonas Foyken, the RBI and integrity engineer at Brunei Shelf Petroleum. Thank you for your thoughts provoking views on the AI, RBI, and the future of asset integrity. And Mr. Daniel, thank you, the inspection advocate and investor, for driving this session smoothly and productively with your practical expertise on modern inspections and emerging entity technologies. We hope today's session has proved valuable insights into how inspection continues to shape the future of safety in the oil and gas industry. If you enjoyed our sessions, we encourage you to stay connected with One Stop Entity website for the future editions of NDT Talks, industry news, and technical resources with the upcoming events. Follow us on LinkedIn and subscribe to our YouTube channel to check out the recordings of our previous NDT Talks editions. Thank you once again, everyone, for joining us. Stay safe, keep learning, and we'll see you at the next NDT Talks.
Thank you.
Thank you.
Bye.